Diagnostic Trouble Codes, or DTCs, are a set of codes that are specific to each vehicle manufacturer and are stored in the ABS control unit when a system problem is detected. DTCs can be hard codes or soft codes. Hard codes indicate that a failure is present at the time of testing, while soft codes are stored history codes of events that have happened in the past. DTCs can be retrieved from the control unit using either a diagnostic scan tool or by following the manufacturer's instructions to enter the diagnostic mode and retrieve the codes through the blinking pattern of the ABS lamp in the diagnostic mode. Hard codes indicate problems that currently exist and allow you to go directly to the diagnostic flow charts to quickly identify the cause of the problem. Soft codes, or events that have happened in the past, require that you test for conditions that could cause an intermittent problem in the affected circuit. Soft codes often result from loose or corroded connectors, so never disconnect them until you try a wiggle test on the connector to try to duplicate the problem. Disconnecting and reconnecting a connector before doing a wiggle test may correct a condition, but you would not necessarily identify the source, and you could spend a lot of additional time checking other connections and components unnecessarily. In a typical ABS system, diagnostic trouble codes can be set by high resistance in a circuit, low resistance in a circuit, open circuits, shorted circuits, intermittent voltage spikes, intermittent open or shorted circuits, low fluid levels, or low system pressures in the accumulator. High resistance in a circuit is often caused by loose or corroded connections or by frayed wires. Sensors with partially open windings in their coils will also have high resistance. Low resistance in a circuit is usually caused by partially shorted wires in a sensor coil winding. High resistance in connectors can be confirmed with a voltage drop test across the connection using a digital multimeter. Voltage drop tests must always be done with current flowing through the circuit. High or low resistance of a sensor can be checked using a digital multimeter using the ohms function. Test for continuity or resistance using a digital ohm meter must always be done with the circuit unpowered. Open circuits have a break in a wire or open wires in a sensor. Open circuits can be detected with a digital multimeter using the ohm meter function. Open circuits will have infinite resistance, as current cannot flow across a break in the circuit. Shorted circuits mean that the current in a circuit is finding an alternate path to ground. Shorted circuits will have continuity to ground when tested with a digital multimeter using the ohm meter function. Intermittent voltage spikes, high circuit resistance or low circuit resistance, will cause the sensor voltage to be out of the normal range of operation. The best way to check for out-of-range conditions is to use a digital oscilloscope to monitor the signal as the signal is generated. Voltage spikes can be captured on the flight recorder function of the digital oscilloscope. Many scan tools now incorporate digital oscilloscopes into their functions. Low fluid levels can be visually confirmed by checking the fluid reservoir. Low accumulator pressure in the ABS actuator is an indication of a failing or failed ABS high-pressure pump on integral-type ABS systems. Follow the troubleshooting procedure in the manufacturer's service manual to confirm the failure. Failed high-pressure pumps will require that the ABS actuator be replaced.